So make sure everybody can see. Can everybody see me from where you are? I want to make sure everybody can actually see. All right, so here we go. We've got this cool little deal right here. So we talk about concentration and solubility. One thing we know that's nice and soluble in water would be sucrose, which is what? Sugar. All right, so what I've done is I made these 6 jars here of different concentrations of sugar. Okay, so this one was 90%, 80, 70, 60, 50, and 40. So the other thing to remember when you're dealing with concentration is that sometimes when you've got, well, often, the more concentrated a substance, the more dense it would be, right? So if we've got more solute in this purple one than we do in this red one, then you should expect the density to, what's the word I want? You should expect it to be obvious if you stack them gently. So what I did is, I don't know, you may have, if you've ever, I don't know if you've ever seen it, maybe on a TV or in a movie, but bartenders do this actually with certain alcohols are more dense than others, and they can layer drinks, and it's kind of like a cool bartender trick. But what we're gonna do is we're gonna layer these different densities of color in here. So I'm gonna do the first one, and then if you guys wanna volunteer to do others, you can. So basically how I'm gonna do it is, this one's like almost syrupy, right? I actually did 100 milliliters of water and 90 grams of sugar. So that's like 100 grams, 90 grams, right? So I'm gonna pour this one in here, just a bit of it. We're gonna try and just deal with, really what we wanna deal with is 10. This one, actually I'm gonna do the first 2, because this one doesn't matter so much. We just need to get it in the bottom, and I want it to go to the 10. So this is not the tricky one. We just need it to go to the 10, and then we're done. Okay. And then I'm just gonna rinse it. I'm gonna use it a bunch. So the way you have to do this next part is the careful part. This is the tricky part. This one's the 80 and it's the blue. Oh my gosh, they're so sticky. All right. I'm gonna use my spatula there, like a bartender would use a spoon actually, if you've ever seen them do this kind of trick. So this is where it gets tricky. You have to come in, I'm gonna blow up my whole thing. I may have to come around and swat so you can see. So we're gonna put this way down in here as close to the edge as we can get it. And when you get more in there, it's gonna get easier, right? And then you have to kind of pour it down the side real gently, because the goal is to go slow enough to get it to sit on top. And it'll mix a little, hopefully not too much. There we go. Right up to the 10 line. All right. See what we got so far? That's cool, right? Anybody want to be brave enough to try the green?
Me.
Jack's hand goes up.
Do I just do it the same way you
Yeah,
did
do
the
the same
last
way I
one?
did it, but you're gonna want to get down real low and be real. Careful. Hope that you don't. I'll hold that for you. You got it. Really slowly. That's the trick. Super slow.
But what if the science is made of sugar? I'm just saying.
There you go. There you go. That's good. Look at that. That one goes right. You can see them float up even as they come as bubbles. That's cool.
What if it's 80% sugar? And some water, so it's healthy.
About there. Almost there. There you go. Perfect. Oh, you can see them mixing and settling back. That's really kind of cool. Excellent. Check it out. All right. Who wants to do the yellow one?
Sure.
Oh, Jules wants to try. Let's let Jules come around and try. And Alex, you can do the orange. All right, Jules, you're gonna want to be over there on that side. Okay, now here's the trick: is you're gonna go real. Oops. And I'm gonna hold the bottom of this. Yep. Just go real slow. Watch. See, turn it so you've got the little. There you go. See a little pour in. Get it real close to the. Pour it right onto the spatula so that it oozes down. There you go. There you go. Right to there. Perfect. Look at that. That one's a little harder to see, but it'll settle and you should be able to see it. There it goes. I see it coming to the top a little bit. Nice job. All right, Alex, you're gonna do the orange? And it's probably high enough now that you don't have to do too much tipping. Yeah, so you probably don't need me to hold the bottom. You just be real careful. All right, here goes the orange, gang. That's good, you got it.
Don't let us down.
Whoop, slower, going down too low. Good. Almost there. There you go, perfect. Check it out. This goes right in here. Wait a minute, are you right-handed or left-handed?
This is the hand.
Okay, so you're gonna pour with the hand you write with. And you wanna hold this one like that and go real slow, a little higher, right there, really slowly. There you go. Just pour the whole thing in, just go slowly. There you go. You got it. Nice and slow. Look at this, gang. We did it. Nicely done. Check that out. Very pretty. So, here's what y'all accomplished. Let me turn it to the camera first. There we go. Very cool. And I'll turn it towards y'all. Here you go. Can you see? Really cool. I mean, look what you did. So I'm going to take yours, and I'll put it right here for a second, and I'm going to show you mine. Now, ours are separated. This is mine that I made earlier, right? They're separated by what? What's separating the layers? Density, right? Concentration and density. But is there, the solute and the solvent are the same the whole way through, right? So what's going to happen if I shake mine?
It's gonna just combine.
Yeah, it's going to just combine if I shake it, right? So I'm not going to shake yours because you worked very hard on it. But I'm going to take mine. Whoop! Now, if it's just water and sugar. Whoop! If I leave it, is it going to settle back down?
No.
No, it won't. But if I had oil in there, would it settle back down?
Yes.
Yes. Okay, so now I just have what looks like, oh, look at how dense that purple is. It's still there. Look at that. Put this on even tighter. Come on. There. Look at that. There it finally went. So yeah, because the solvent and the solid are like, right? You're not going to get any change if you shake them up. They're just going to stay that way forever. They're never going to settle back the way it would if they were not soluble in each other. All right, the next thing I want to show you is about supersaturation. Who can tell me about supersaturation? What does that mean? Nobody knows about supersaturation?
I believe that's when there's too much solute in a solvent.
Too much. Okay, so supersaturation, that's really close. Supersaturated solutions, and everybody's going to want to be close up for this so they can see. I'm going to give Lily the honors, but... So, supersaturated solutions. Cole, are you listening? Everybody listening? So you can stay on that side, I think. Actually, no, come here. You're good here. All right, so supersaturated solutions are those that have more solute than the solvent should be able to hold. Should. And that means at a given temperature. So how do you suppose you would make a supersaturated solution?
Heat it up, put it in,
Heat it up. Right. So what I have here, first off, does anybody know what kind of glassware this is?
It's a
The clear kind.
It's a kind of flask. Do we know what kind of flask it is?
It's a hydro flask.
It's called a volumetric flask, okay? Anyway, so what's in it is actually this stuff right here, which is sodium acetate trihydrate, all right?
Hot ice.
And so this stuff here, I took 160 grams of it, which in this size beaker came to about there. And I put in only 30 milliliters of water, which is, way down here. So that's just water. Very little water, all right? And then I put it on the heat on my hot plate with my magnetic stirrer and let it go, and it went for a long, long time, and eventually all of the solids dissolved, all the crystals dissolved. This stuff is super sensitive, meaning like if you jar it around too much or bump it, it might mess up before we're ready. So what we're gonna do here, Lily, I'm gonna give you one crystal of this, okay? Yep, and this stuff here, this is what it looks like. It's not harmful. Actually, it's in some foods as a preservative. So you wouldn't want to eat it, but. So I'm gonna give Lily this one little crystal. Okay, see your hand? All right, now, do you remember last year, those of you who were here, do you remember when we did the ice, the bottle with the ice where we got the water super cooled and we banged it on the table and suddenly it turned solid? Okay, when you have, think about this, when you have molecules in a liquid form, are they more organized or less organized than a solid?
Less.
They're less organized, right? Think of it this way, all these molecules in here cannot find their way because they've got too much energy, they're moving around, they're slipping past each other, they're disorganized. Lily's gonna organize them by basically introducing them to the one organized solid particle. So everybody wants to be able to see because you need to be where you can see, okay, because it's fast. So whenever you are ready, Lily, can everyone see? Alec, can you see? Eleanor? Make sure you can see. And then Lily, when you're ready, your only trick is to make sure you drop it straight and it doesn't stick to the sides. If it sticks to the sides, I'll give you another one. Okay, you watching? It stuck to the side. You failed, Lil. Here, let me give you another. No biggie. Great failure. Here's a. Here. There's like 2 or 3 in there. There you go. That should be able to get it right in the middle. Right down the middle. You ready? Oh, there it goes.
Why is this? It's a cloud.
That's pretty cool.
There you are. Now, touch that, Jules, and tell me what you feel.
It feels really warm.
It feels really warm, doesn't it?
It looks like it was.
So what kind of reaction was this? You can pass it around gently. Have you ever used the hand warmers that you squeeze and then suddenly they do that? It's the same exact chemical. That's what they use. So if you've ever used one of those hand warmers, that's how they work. Good deal. All right. Let me move this back here. So does anybody know what this jobby-do is that I have here in front of you? This thing. Nope. Nobody knows what this is? This is a burette, and I need a stool because I'm short. Does anybody in the back row who can't see, are y'all listening? Anybody in the back row who can't see the numbers, would you like to guess how much this holds?
A lot.
So
I'm gonna concur with that answer.
this is what's wild. It holds 50 milliliters, which is the size of this beaker right here. It holds very little. And so when we do these, we're going to use these in a couple weeks. And actually what I'm going to do first is I'm just going to run some distilled water through it. So this is 25 mils, is actually half the volume. I don't need to use the whole thing.
That was satisfying.
So I know, right? And I'm going to let it come out fast for a minute because I want to make sure it's very clear the whole way down, nice and clean. But when you guys are using it with acid and base titration, what you do is you get it to the point where it just drops, 1 drop at a time. And then you count the drops. See? Look at that. And you'll count them, and you'll do that by, like, you'll add an acid to a base, for example. And when you do this, it's super cool because then you can see how many drops it took to neutralize or whatnot. So I want to get it to right about. Now, I did this last night, and it messed up, and I was really mad. So I'm hoping it doesn't mess up today because it took me like an hour to clean. There are ways to do this that are not as involved in cleaning, but I'm picky.
Yes, that's
This is just water. All right, so that's just distilled water. Now, I'm gonna take this guy out of the way, and I have this glass plate here, okay? Just a glass plate. And I'm gonna put, just glass plate, nothing exciting.
Oh no.
No, it's going
And I'm gonna put, let me move it forward a little bit. That's what we're aiming for. So I just need to put a little pile right there, okay? Right under that. No, nothing's gonna explode. Okay. Well, I hope it doesn't. How about that? Yeah, here's where I have to be quick because what happened last time is,
It exploded.
well, no, that was different. This business is the same stuff we just used, okay? But last time, some of it started to dry, and then the crystallization started at the top. So my goal is to actually put in some and then put a little water on top. That should keep that from happening because it's really terrible when your burette clogs. So I'm gonna go up high. I'm gonna add in some of this. Oh, shoot, there it goes already. Suckers. Yeah.
Oh.
See, it already did it. Hold on. The last thing I want is for it to get down in here. That's a pain in the butt. It's that there. Come on.
I knew it was up there.
It's not fun when you do that. Hello, now I'm dropping things. Okay, hold up.
Oh, it's going down.
Oh, that's okay. Enough of it should go. Maybe some of it. Look, well, if not, I'll get a pipette. Nope, I'm gonna need a pipette. Dude on YouTube made this part look easy. I'm like, this is not easy with a burette. Fine, we'll do it without the burette. So we'll do. Look at that.
Oh my god.
See that? Because you know what I didn't. All I did was jar it, right? Like all I did was move it around. That's how sensitive it was. Just the moving it around was enough to turn it.
Let's see how it works. And we'll cross our fingers that in fact it's going to start building up. And yes, it is. Stalagmite formation. There it is. Millions of years happening before your eyes. This is Mammoth Cave cut down into a 20-second process. Are you counting the drops? That's another whole process. We can do reaction rates here.
Kind of thing.
Okay, I have one more container. We'll try it this way. So let's do one more thing. Since my burette doesn't want to cooperate, this is not as bad as last night. Last night it solidified. It didn't do that until the end. It solidified from here down. I was not. Okay, let's try it one more time. The less exciting way. I better. Now the cool thing about this stuff is, if I heat this is still hot. Actually, this is really hot now. If I heat this back up, I can use it again and again and again and again. Careful, Drew, watch the in front of you. All right, see if I can get this open without agitating it. That's the trick. Okay, here we go. Oh, there it goes, hold on. No, don't do it. No, shoot, look, it did it before I could do it. You can't, if you can make it work without it doing that, which is what it just did, it'll build up. So I'm gonna try and see if I can heat it. You can actually nuke it.
Oh, yeah.
And I'll save my nuke it. You can nuke it, yeah. I'll get more than So you guys wanna check your progress real quick and see how everything's going.